Hello everyone, this is Florence Deepa, Assistant Professor, Department of Computer Applications, Bishop Weber College, Trichurapalli. Welcome to the presentation on merge sort. I am excited to guide you through this fundamental sorting algorithm today. Today, we will dividing into merge sort, a powerful and efficient sorting algorithm. At its core, merge sort is based on divide and conquer problem, in which we will explore in detail. Think of it as a team effort, breaking down a big task into smaller and manageable pieces. Merge sort is a classical example of sorting algorithms that leverages the divide and conquer strategy. This pattern is incredibly versatile and widely used in computer science. It mirrors how we often use to solve the problems in real life. Generally, it will break down it, conquer each part, and then combine all the solutions. Now, let's explore deeper into how the divide and conquer approach applies specifically to the merge sort. We will break down the process into its key steps: divide, conquer, and combine. Understanding these steps is crucial to grasping the algorithm efficiency. This algorithm has two processes. One is merge sort and another one is merge. In this merge sort algorithm, the whole array is divided into two partitions and it is recursively done until each partition contains an element. The following figure represents how the merge sort process is going to be executed. First, the divide process is executed. If S has two elements that needs to remove all the elements from the S, it will be divided into two sequences, S1 and S2. It is recursively done. The sorting procedures will be defined in the next cases. as a continuity. The S1 will divided into S3 and S4, and next the S3 will be divided into S5 and S6. This diagram depicts the merge sort process of the merge sort algorithm. For an example, there is an array of 8 elements which is divided into 4 and 4, and further it will be divided into 2 and 2 and 2. And finally it was divided as a partition contains an element. And in the second stage, the two partitions which contains an element will be merged as a one, where the sorting procedure is combined. And finally, we got the sorted result too. In the given merge sort algorithm, low, it will be start from the low to the highest definitions. First, it will check whether it is low. If it is low, then it will divide it by its midpoint using the formula low plus high divided by 2. And first it will call from low to mid, that is the first partition, and it will call the second partition mid plus 1 to high. In recursively, it is called the merge the sort, which is start from low to mid and to high. The algorithm merge contains three parameters: low, the starting index of the first half of the array; mid, the mid index which separates the array into two halves; and high is the ending index of the second part. This algorithm uses a while loops to iterate the both halves, while the h is less than or equal to mid, and as well as j is less than or equal to h. It will compare the element that is placed in h as well as j. If the smallest element is placed in the first partition of the array, then it will be moved on to the temporary array A. If it is small, then the second part of information will be loaded into the temporary buffer B. And further it will be recursively called, and next it will check whether h is greater than mid, that is the first half is exaggerated. Then the remaining elements from the second half will be copied to the B. Otherwise, the remaining half from the first half are copied. And finally, the copied informations from A, that is the original array, will be back from the B, that is the temporary buffer. Thanks for watching.